Good morning children, and welcome back to your chemistry class. So yesterday we had studied that the long form of periodic table, it can be further divided into 4 blocks. And what are those blocks? S block, P block, D block and F block. And what is the basis of it? On the basis of electronic configuration of the elements. Okay. So today we are going to study about the characteristics of these block elements. So to begin with, we are going to talk about S block elements first. Yesterday I had shown you what are the S block elements, right? The elements with NS1 and NS2 configuration in the outermost shell, they are your S block elements. Clear? Elements with NS1 configuration in the outermost shell, they are from which group? They are group 1, right? And NS2, they are from group 2. So what is group 1 element called, or 1A I should say? They are called as alkali metals, and group 2 is called as what? Alkaline earth metals. So this is what we had earlier studied, right? Now talking about the certain electronic configurations of S block elements, so that you revise your configuration also. They are like lithium, sodium, potassium. Lithium is at 3, sodium is 11, potassium is 19. Okay. So what do we know about them? Let us configure these atomic numbers. This is 1s2, 2s1. What is this? 1s2, 2s2, 2p6, 3s1. Let us configure 19. It is 1s2, 2s2, 2p6, 3s2, 3p6. This is 10, 16, 17, 18, 3p6, 4s1. Okay, these are your alkali elements. Then you have rubidium, cesium and all that. Followed? Now alkaline earth metals, they are like your beryllium with atomic number 4. Then you have magnesium with atomic number 12. Then calcium 20. So if you configure this, what are you going to see? It is 1s2, 2s2. This is 1s2, 2s2, 2p6, 3s2. This is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. So what did we see here? It is NS1, NS1, and here it is NS2. This is NS2. Clear? So what do we know about the properties of these elements? Right? The S block elements, I did not include hydrogen over here. Generally we exclude hydrogen from S block elements, though they are definitely placed there because of the unique nature, the dual character. They are placed there, but when we are talking about alkali metals, we generally avoid writing hydrogen. So I did not write hydrogen over here. Okay. So now let us talk about certain properties of S block elements. Firstly, we know that these are soft metals. Okay. And they have low melting point and boiling point, right? Even the ionization energy, if you know, as we go down, the ionization energy also decreases. So alkali elements or your alkaline elements, as we go down in the S block, though ionization energy always decreases from top to bottom, but when we are talking about S block elements, let us only be restricted to S block elements and discuss about it. So I say over here that ionization energy also decreases. Now what do we know about oxidation state? Oxidation state of group 1A. Okay, oxidation state of group 1 is +1 and that of group 2 it is +2. Clear? Then these elements, these S block elements, they are highly reactive. They are highly reactive. Now why are they highly reactive? What is the reason? Because they are strongly electropositive metals. They are placed just next to your zero group. They just have to release one electron to become stable, and therefore they are highly reactive. Okay. Then they form colorless ions. Right? They are mostly ionic compounds. And even they are diamagnetic in nature. Right? They are also good reducing agents. They are, if you remember, all the metals, these are good reducing agents. Right? So this was all about S block elements that we should be knowing. We next move to P block elements. Okay. Let's talk about P block elements now. These P block elements, their configuration is NS2 NPX, where your X ranges from 1 to 6. Okay, so it could be 1, 2, 3, 4, 5, 6, like that. So in the P block elements, the electrons, they are always filled in the p orbitals as the atomic number increases progressively. The electronic configuration of the P block element, it always begins from NP1, right, and it will complete where? At NP6. So it is written like NP1 or maybe NP2 or maybe NP3, and it ends where? With NP6. So these P block elements, they constitute the elements of group what? From group 13 to group 18. They are all from your P block elements. These P block elements, the number of valence electron, it also varies from where? 3 to 8. What is this? The valence electrons are from 3 to 8. It varies. Now, what are the characteristics of these P block elements is what we should know. That they include both metals and non-metals. Okay. Then what else we know about it? They have high ionization energies, and they also mostly form the covalent compounds. Have high ionization energies, then form covalent compounds. Okay. Then they also form acidic oxides. They form acidic oxides. Then they also show variable oxidation states. Show variable oxidation states. Okay. Then the metallic character among the P block element, it increases on going down the group, but it decreases when we move from left to right. And the noble gases, they show very low chemical reactivity. Why? Because they are completely, their orbitals are always completely filled. Right? They have 8 electrons in their outermost shell also. So we can say that they do not show any reaction. Whereas your zero group elements, where are they found? They are also found in your p block, right? Now we need to understand over here how to calculate the number of valence electrons in the p block elements, right? So there is a certain formula that you should always remember. That is, in p block elements, you always should remember when you have to find out number of group, okay, then it will always be number of valence electron plus 10, followed. And if you have to find out number of valence electrons, then you should always use this formula, number of group minus 10. Okay, so let us take few examples over here, the number of valence electrons in group 13. How to find out valence electron in group 13? What did I say? Number of valence electrons, what have you to do? Number of group you need to know, minus it from 10. So what is the group 13? 13 minus 10. So what are the valence electrons in this group 13? They are 3. Right? So what kind of electronic configuration is this going to show you? It is going to show you NS2, NP, NP1. 2 and 1 makes it 3. Understood? Let's take another example. Okay, then valence electron in group 14. How to find out? This will be 14 minus 10, which is equal to 4. Now give me the configuration of it. So since it is 4 electrons, so NS2 has to be first filled. Now what is left? NP2. Have you understood this? Okay. Then take another example. Valence electron in group 17. So this will be 17 minus 10. This is equal to 7. Okay. So configure this. This will be NS2 NP. 7 minus 2 makes it 5. So NP5. I hope this P block is also very clear to you. Now we move to now the S block, okay, and the P block elements, they are together termed as representative elements. Okay, they are what called as representative elements, and if you have observed, then the outermost shell is incomplete. Okay, so group 1 and 2, the alkaline earth metals, and group 13, 14, 15, 16, 17, 18, they are termed as representative elements. Let us also talk about noble gases, which are also found where? In the P block, right? The elements of group 18, they are 18 group elements, they are termed as noble gases. They do not interact with other elements. Why? Because the outermost shell is complete. They do not have any combining capacity. Their valency is 0. So chemically they are inert in nature, right? So what are some of the examples? Like helium, neon, argon, krypton, xenon, radon, UO. Okay, so you need to remember their atomic numbers, otherwise your electronic configuration you will not be able to do. So helium, it is 2, neon, it is 10, argon, it is how much? 18, krypton is 36, then xenon is 54, Argon is 86 and this is 118, the last element, right? And how can you configure it? So this will be like 1s2. How can you configure it? Neon? It is 1s2, 2s2, 2p6. Then argon 1s2, 2s2, 2p6, isn't it? Then 3s2, 3p6. This can also be written as, look over here, this is neon. So this can be written or neon 3s2, 3p6. Clear? Now, how to write down krypton? Krypton is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Let's count 10, 20, 36. Okay. So look over here. Argon is 18. Till here it is argon, isn't it? So it could be written as what? Argon 4s2, 3d10, 4p6. I hope it's very clear to you. You must have already done all that before. So what kind of configuration do these noble gases they show? They show you ns2 np6 electronic configuration. Now see over here, ns2 np6, all the orbitals are filled. Therefore, they do not have a sharing capacity, no combining capacity, no valency. Therefore, they are inert in nature, also called as noble gases. Now we come to D block elements. Let us talk about D block elements. So these elements which are placed between S and P block, right? They are termed as D block elements. Okay. Then these are also called as transition elements, and these are subgroup B elements also, and these are mostly metals. These are mostly metals. Okay. What kind of configuration do they show? They show n-1 D. This ranges from 1 to 10. Okay. Then ns, it ranges from 0 to 2. This electronic configuration of the D block elements. Okay. This is the general configuration. Now I will show you the configuration of certain elements also based on this general configuration given to you. But before that, let us understand certain characteristics of the D block elements. So as I told you, they are found between S block and P block, the center one. They are called as D block elements, right? They have high melting point and boiling point, except there's an exception over here, except mercury. Okay, they have high melting and boiling point. Then second point, they are malleable and ductile. They are malleable and ductile also. Then they form ionic as well as covalent compounds. Form ionic and covalent compounds. Clear? They show variable oxidation states. They show variable oxidation states also. Then even they are good conductors of heat and electricity. Good conductors of heat and electricity. Clear? Then they always, or they generally form colored compounds. Generally, they form colored compounds. They form colored compounds, okay, and they are also good catalysts. If you remember, most of the catalysts, they are found in D block. Is that clear? And what do we know about the ionization energy? The ionization energy always is between the S block and the P block elements. So ionization energy lies in between S block and P block elements. Is this point clear to you? Now let us do some configurations to make ourselves understand about how the configuration of the D block element is done. So some examples. Let's talk about scandium, which is atomic number 21. So let's configure this. How are we going to configure it? It is 21. So we can take argon over here, okay, and then 3D1 3S2, okay, 3D1 3S2. Then you can nickel atomic number is 28. Let's configure nickel. Then we have argon, okay, then argon is how much? 18 finished. How much left? 10 still left. So how are we going to write? 3D will come first. 8 4S2. This will be the configuration of nickel. Take one more example. Zinc is also one of its members and its atomic number is 30. So configure this also, 18 till argon finished. After that we have 3D. It ranges from 1 to 10. So 3D10. This NS ranges from 0 to 2. So 3D10 4S2. Silver is also present in this D block element and the atomic number of silver is 47. So how can we configure this? We talk about krypton. Krypton atomic number is krypton atomic number is 36. So we take krypton over here. 36 is done. How much is left? 36, 46, 10 and one more 4D10 5S1. 36, 46 and 147. So this is how the configuration for D block element is done. F block elements. So these F block elements, the electrons are filled in F orbitals. Okay, there are two series of F block elements in which we have 4F and 5F orbitals that are to be filled up from where 1 to 40. Clear? Then the first series, 4F series, it is called as the lanthanoid series. Okay, and 5F is just called as the actinoid series. Actinoid series. Now they are together termed as inner transition elements. Inner transition elements. Okay. Now lanthanide series, they are rare earth metals. What are they? There are rare earth metals. Okay. And actinoids, these are radioactive elements. Radioactive elements. Clear? Then many of the elements of actinoid series, they have been prepared by the nuclear reactions, and therefore the chemistry has not been thoroughly studied about these particular elements. Then let us look at the electronic configuration of F block elements. What is it? It is N-2 F, which ranges from 0 to 14, then N-1 D, which ranges from 0 to 1, NS2. So this is the configuration that we need to remember for F block elements. We will do the configuration of certain elements, so don't worry about that. So firstly, let us understand the characteristics of these F block elements. These are all mostly metals. Okay. Then what do we know? They have a high melting point and boiling point. They show variable oxidation states, right? Then they usually form colored compounds. They form colored compounds and so form complex ion and coordination compounds. Also form complex ions and coordination compounds. Clear? So these were some of the properties of F block elements. Now let us configure handful of elements to understand this particular general electronic configuration of F block elements. So let us see lanthanum, which is 57. So how is this configured? I am not going into that long configuration. The short one, let us see xenon. Okay. Xenon means 54. Now how much is left? 5D1 6s2. 6s2 5D1. Okay. Similarly, let's talk about actinium, whose atomic number is 89. So how will you configure this? Then for this we will take radon, whose atomic number is 86. 86, and how much left? 3 more left. So how will we configure this? This will be Rn radon 6D1 7s2. So this is how the configuration can be done. So the last part over here, the question can be like actinides and lanthanides, they are placed separately at the bottom of the periodic table. Give the reason for this kind of arrangement. So if lanthanoids, they were placed in the period from where they were brought 6 after lanthanium, right, in the main body of the periodic table, then it would have been too lengthy to accommodate all the 29 elements in that main periodic table, right? So the lanthanoids, which had similar chemical properties, they were placed at the bottom of the periodic table. So lanthanoids, they are placed separately in the periodic table to save the space and also to keep the elements with similar properties in a single row. Okay, so I hope you have understood why the lanthanides and actinides, they are placed apart from each other. And so this I stop over here. Next time I am going to come up tomorrow with the periodic trends in the properties of the elements. Thank you.